So let's talk about mechanical energy then. This is our dart. If we want to find the mechanical energy, that is represented by the kinetic energy plus the sigma potential energy. However, if we don't know these two, we can represent these with an equation as well. So if this equation represents kinetic energy, 1/2 times mass times volume, not volume, velocity squared. And the potential energy, in this case represented by the potential gravitational energy, would be mass times gravitational acceleration plus height. So let's say we're talking about the dart that we shot. So let's say it's a heavy dart and it weighs 1 kilogram. Okay, this is the mass equals m. That's important. And then we have the velocity. So say we shot it at, 5 meters per second. So the dart was shot at 5 meters per second. And say it was traveling horizontally, which it was because we shot it. It would be, let's say, I shot it at arm's height. So let's say I'm really short, let's say 3 meters. So that's height. So if we have the mass, velocity, and the height, and we have this equation, we can just start plugging. So mechanical energy equals 1/2 times the mass, which is 1 kilogram, times the velocity squared, which is 5 squared. That's plus the potential energy, which is the mass, which is 1 kilogram, times the gravitational acceleration, which we all know is 9.81, as we all should, times the height, which is 3. So this equation right here, it's kind of long, will give us the mechanical energy. So now we can just solve it. Okay, get your calculators out. I'm not very smart, so this is gonna take me a little bit. So 1/2 times 1 is 1/2 times 1, anything times 1, 0.5. 0.5 times 5 squared. You do 5 squared is 25. So 0.5 times 25 plus 1 times 9.81 equals 9.81 times 3. I'm not gonna, I don't know this because I'm not a human calculator. But I know half of 25 is 12.5. So 12.5 plus 9.83. That would be, let's just do 9 times 3 because I'm stupid. That's 27. So 27, 8 times 3. What's 8 times 3 is 24. So 27 plus 24 would be, it would be 27, 29. We'll call it 29. I don't know if that's right. I don't really care either. Plus 29. And then you add those together. That should be pretty easy. That's just like 20, 30, 9 plus 2, 9 plus 2 is 11, 2 plus 1, 3, 4, 11, 41.5. So this means the total amount of mechanical energy that we have, ME equals 41.5. And since we always measure energy in joules, the answer to our problem is mechanical energy equals 41.5 joules, roughly. That's not exactly right. You guys have calculators, you do it. I'm not very literate in math, but that should be correct. Yeah, and that's how you solve for mechanical energy. That's how mechanical energy is conserved. And if you just solved for your kinetic energy and your potential energy, you just solved for those, which in this case was, which was represented by 1/2 times mass times velocity squared, and this was represented by mgh plus 1/2 kx squared. This right here is elastic potential energy. In this case, we had no Noah, why are you talking to me? You know I'm doing something. What?